مش كل سقالة آمنة. الغلطات دي ممكن تقتلك.
Welcome to The Explainer. Today we are cutting right through the complexity of OSHA's rules to focus on the two absolute pillars of scaffold safety. You know, if you understand these two principles, you understand the key to preventing a catastrophic failure. So let's just jump right in. First things first, let's establish why this matters so much. Every single year, in construction alone, 79 people go to work on a scaffold and they don't come home. And for every one of those tragedies, you have thousands more injuries. We're talking nearly 10,000 workers getting hurt in scaffold-related incidents every year. These are not rare events. This isn't like getting struck by lightning. It happens with alarming regularity. So here's the crucial point. These aren't just statistics. They're a clear signal that safety can't ever be left to chance. It's not about being lucky. It demands a deliberate, robust system. And that's exactly what OSHA's general requirements are built to create. That system, it really rests on two fundamental pillars. First, you've got the physical, engineered strength of the scaffold itself. And second, you have the human expertise that designs, inspects, and supervises its use. And you absolutely cannot have one without the other. So let's dig into that first pillar, the raw physics of what keeps a scaffold standing. This all comes down to one thing, its capacity, what it can actually safely hold. And to really get a grip on capacity, you have to understand what OSHA calls the maximum intended load. Now, this isn't just the weight of the people on it, it's everything. Think about it. Every person, every tool, every bag of mortar, every single piece of equipment, it's the total weight you can reasonably expect to be up there. And here's the number at the very heart of the OSHA standard, 4. The rule, and this is section 1926.451A1, for those of you taking notes, demands that a scaffold has to be able to support its own weight plus 4 times that maximum intended load we just talked about. This isn't a suggestion, it is a massive built-in safety factor. And that 4-to-1 rule applies to the entire system. It's not just the deck they're standing on. We're talking about every leg, every cross brace, every single connection point. Each individual component has to be up to the task of supporting 4 times the load it will ever realistically be asked to carry. That right there is engineered strength. Okay, so you can have a perfectly engineered structure, strong as an ox, but it's only half the equation. It can still fail if it's not managed correctly. And that brings us to our second pillar, human expertise. OSHA actually defines 2 very specific, very different roles to make sure things are safe on site. On one side, you have the qualified person. Think of them as the architect or the engineer. This is the person with a degree or a professional certificate or just deep, extensive experience who actually designs this scaffold system. Then, on the other side, you have the competent person. This is your on-site supervisor. They're the ones overseeing the crew that builds it, conducting inspections before every single shift, and this is critical, they have the full authority to stop all work immediately if they see a hazard. And just so there's no confusion, OSHA puts that authority right there in black and white. This regulation makes it crystal clear. Nothing happens with that scaffold, building it, moving it, taking it down, without the direct supervision of that designated competent person. So we have the design and we have the daily inspection. How do these two pillars actually work together on a real job site to create a complete safety system? Well, it's a workflow. It all starts with the qualified person, who engineers a scaffold that meets that crucial 4x capacity requirement. Then, the crew builds it, but only under the watchful eye of the competent person. Once it's up, that same competent person inspects it, not just once, but before every single shift begins. And only after it passes that inspection can anyone start working on it. So, to bring it all home, scaffold safety really does stand on these 2 pillars. Pillar 1 is that engineered strength, designed by a qualified person and built to that non-negotiable 4 times safety factor. And Pillar 2 is human expertise, supervised and inspected every single day by a competent person who has the knowledge and the authority to make sure it's safe. So this all comes down to one critical question for every single worksite. You have to trust the engineering was done right, but who is the person on your site right now with the authority to inspect it and say stop? Who is your designated competent person? All right, let's get right into the nuts and bolts of OSHA's platform construction standards. We're focusing strictly on 1926.451B today. These aren't just suggestions, they're the rules that keep you safe when you're working at height.
So first things first, the actual surface you're standing on. The number one foundational rule is that every single platform has to be fully planked or decked. This is what creates that solid, reliable base you need for any kind of work.
So what does fully planked or decked actually mean on a job site? Well, it's pretty straightforward. It means you have a solid floor under your feet. The entire space, from the front legs of the scaffold all the way back to the guardrail, has to be completely covered. No gaps, no holes. Nothing to trip on and nowhere for a drop tool to fall through.
And when OSHA says no gaps, they get really specific. The maximum space you're allowed to have between your planks is just 1 inch. Now, there is a tiny exception for when you're working around the uprights, but for pretty much every other situation, that 1-inch rule is absolute.
That 1 inch might not seem like a lot, but it's a huge safety feature. Just think about it. So many job site accidents involve falling objects. This rule is specifically designed to stop a dropped bolt, a nut, or a small wrench from becoming a serious hazard for anyone who might be working below you.
Okay, so we've sealed up the gaps between the planks. Now let's talk about the total width of the platform. Because having a floor is one thing, but having a real, functional workspace is another.
The standard is crystal clear. Every platform and every walkway has to be at least 18 inches wide. And that's not some random number. It's really the baseline for giving you a stable, confident footing, especially when you're carrying tools or materials.
You know, this 18-inch minimum is what makes the difference between feeling like you're on a balance beam and knowing you're on a stable platform. It gives you the room you need to move, to turn around, and to get your work done without ever having to worry about where you're putting your feet.
So, we've got a solid, wide platform, but what about the ends of the planks? This is where the physics of leverage really come into play, and OSHA has some very precise rules to make sure a platform plank never turns into a seesaw. The first rule you've got to know is that each plank has to extend at least 6 inches past the center of its support. That gives it a stable footing. The only time this doesn't apply is if that plank is physically locked down with something like cleats or hooks. But here's where it gets a little more detailed. It's not just about a minimum overhang. OSHA also sets maximums to prevent tipping. For any plank that's 10 feet long or shorter, the overhang can't be more than 12 inches. If the plank is longer than 10 feet, you get a little more leeway, up to 18 inches.
And the standard literally tells you why these numbers are so important. This whole system of minimum and maximum overhang has one single purpose: to prevent tipping. If you step on a plank with too much overhang, it can flip up in an instant. These measurements are the engineered solution to stop that from ever happening.
And finally, let's talk about how you connect platforms to make a longer walkway. You can't just put the planks end to end and call it a day. There's a very specific and required way to overlap them safely. The rule here is simple but absolutely critical. Any overlap has to happen directly over a support structure, never in the open space between them. And that overlap needs to be a minimum of 12 inches, unless of course the planks are nailed or otherwise fastened together. In the end, every number we've discussed, 1 inch, 18 inches, 6, 12, it's all part of a system. These aren't just arbitrary rules. They are the carefully calculated physics of safety, making sure that the platform under your feet is the last thing you ever have to worry about. All right, let's jump right in. We're talking about one of the most crucial things when it comes to supported scaffolds: stability. Now, the rulebook for this is OSHA Standard 1926.451C, and we're going to break down exactly what you need to know to keep things safe.
So it all really boils down to this one simple but super important ratio, 4:1. You can think of this as the magic number, right? It's what OSHA uses to figure out when a scaffold is just getting too tall for its own good and is at risk of tipping over. It's really just basic physics, you know? The taller a scaffold gets compared to its base, the higher that center of gravity climbs, and the easier it is for the whole thing to go over.
Okay, so take a look at this. It lays it out perfectly. You're basically just taking the total height of the scaffold and you're comparing it to its narrowest point at the base. It's that simple. If that height is more than 4 times that base width, boom, OSHA flags it as a tipping hazard. And that's not something you can ignore. It has to be dealt with.
And here it is, straight from the source. This isn't a friendly suggestion or a best practice. It's the rule. The second you cross that 4:1 line, that scaffold has got to be restrained so it can't tip. Period. This is absolutely non-negotiable. We're talking about the integrity of the whole structure and, more importantly, the safety of every single person on or even near it.
So how do you actually do that? How do you restrain it? Well, you use what are called guys, ties, and braces.
These are basically just secure connections that you use to anchor the scaffold to a stable nearby structure. But here's the key detail, and it's one that a lot of people get wrong. Where you put them is just as important as using them in the first place. OSHA is very clear on this. They have to be installed right where the horizontal parts support both the inside and the outside legs. That's how you make sure the entire frame is locked in.
And OSHA gets really specific about the spacing here. There's no guesswork. Vertically, it all depends on how wide the scaffold is. So for your narrower scaffolds, we're talking 3 feet wide or less, you need a tie every 20 feet. If your scaffold is wider than 3 feet, you get a little more room, every 26 feet. Now that top tie is also super important. It has to be placed so it's still within that 4:1 ratio from the very top of the scaffold. And then going across horizontally, you need ties at each end and then every 30 feet in between.
All right, so we've talked about securing the top, but that's really only half the story, right? A scaffold is like a building. If the foundation isn't solid, the whole thing is coming down. It has to start with a rock-solid foundation. So let's dig into the rules for what the scaffold actually sits on.
And again, you'll see OSHA doesn't mess around here. The language is crystal clear. Every single vertical piece of that scaffold, every pole, leg, post, you name it, has to be sitting on a proper foundation. And the regulation even tells you what that means. It specifically calls out 2 things you need: base plates and mud sills.
And this picture shows you exactly what we're talking about. See that metal plate? That's the base plate. Its job is to spread out the weight from the scaffold leg. Then, underneath that, you've got the mud sill, usually a solid piece of wood. That's what stops the whole thing from sinking into the ground if you're on dirt or something soft. You put them together, and that's the firm foundation the regulation demands.
Okay, one more critical piece for stability. You have to make sure every single leg is perfectly plumb. That just means straight up and down, not leaning one way or the other. And, of course, it has to be braced right. This isn't about making it look pretty. It's about making sure all that weight goes straight down into the foundation like it's supposed to. The moment you get any lean, any sway, you're creating dangerous sideways forces, and that's exactly what can lead to a collapse.
So, we've gone over all the do's. We know how to support a scaffold correctly. Now let's talk about the don'ts, the things you should absolutely never, ever do.
This rule is about as simple as it gets, but you'd be surprised how often people break it. You just can't use random, unstable stuff to prop up a scaffold or its platforms. It's a shortcut to disaster, plain and simple.
And this right here, this is exactly what we're talking about. Stacking up loose bricks, cinder blocks, maybe some old barrels, this is a textbook example of what not to do. It's a recipe for total, catastrophic failure. Remember, the only right way, the only safe way, is a proper foundation with base plates and mud sills. There are no substitutes.
And that covers the essentials you need to know. Make sure you subscribe to our channel so you get all the new updates and get ready for part 2.